Hello everyone, welcome to Science Boot, the podcast that shines a spotlight on the latest in science and technology from Japan. I'm your host, Rem. Today on Science Boot, we are diving into some truly groundbreaking news about earthquake observation from a Japanese university. Imagine this. A study has just shown how we can observe earthquakes with incredible detail using existing fiber optic cables and without needing any traditional seismometers. It's a game changer. First, let's talk about why this research is such a big deal. To study earthquakes properly, we need to accurately observe the seismic waves they generate. For over 100 years, traditional seismometers have been our main tool for this. And don't get me wrong, seismometer technology has come a long way. They've gotten smaller, more precise, and have collected a massive amount of high-quality data. Analyzing all this data has helped us understand so much about earthquakes and even the Earth's internal structure. However, earthquakes observation has always had a major hurdle. You need to install seismometers one by one on the ground. To really dig into things like how seismic waves travel, you need to set up these super sensitive seismometers very close together. But doing that is incredibly laborious and intensive and just not realistic on a large scale. This limitation has always held back our observations. So, with this challenge in mind, a research group at Kyoto University turned their attention to a technology called Distributed Acoustic Sensing, or DAS. This technology can precisely measure how much a single fiber optic cable stretches or contracts along its entire length. The amazing part is you only need to connect a special measuring device to one end of the cable. Because of this, using DAS for earthquake observation has been getting a lot of attention recently. In this study, the researchers used a single fiber optic cable about 50 kilometers long. This cable was already installed along a national highway in southern Kyoto Prefecture, stretching from Kyoto Station all the way to Kyotamba town. Using the DS technique, they measured the strain or this fiber optic cable every 5 meters. Think about that. It's like in-string sensors to measure ground motion at approximately 10,000 different locations along that single cable. When you consider that there are usually only a bit more than 10 conventional high-sensitivity seismic observation points in that same area, this rarely achieved an observation density on a completely different scale. With all this incredibly dense data, the research group made some amazing discoveries. One particularly groundbreaking achievement was developing and successfully using a method to figure out the focal mechanism that the shape and the movement of the fault that caused the earthquake. They did this by looking at the amplitude ratio of what we call seismic P waves and S waves. For the first time ever, they were able to consistently determine the focal mechanism for individual earthquakes. Even smaller ones, from magnitude of 2.2 to 3.4, using this method. Even for smaller magnitude 2 class earthquakes, which were really difficult to analyze with traditional observation networks due to limited data. They could now get the detailed focal mechanism from the DAS records. This revealed that a series of seismic events were actually caused by a specific type of fault movement in the Kyoto zone. But more, in previous similar observation back in 2021. Despite all the traffic noise along with the highway, they successfully captured clear reflection of seismic waves from a deeper structure beneath the Earth's crust, drawing magnitude 2.8 earthquake. It's astonishing that they could capture the distribution of these reflected waves with just one earthquake, when it would have required over 100 small earthquakes with traditional seismometers to do the same. Simulation also suggested that the underground structure causing these reflections is likely a low velocity layer and could even be related to Arima Takatsuki fault zone and possibly even hot spring water deep underground. This research truly shows that using DS technology, we can conduct earthquake observations and investigate underground structure just as detailed, or even more detailed than with our current seismic networks. Here's why this is so exciting. Fiber optic cables are already laid all across Japan and even under the sea. Imagine using this existing infrastructure for earthquake observation. It could mean huge saving in labor, allow for much more detailed earthquake investigations, and be incredibly useful for disaster prevention measures like earthquake early warnings. Of course, DS technology still has its challenge. For example, it currently only measures the movement along the direction of the cable, unlike traditional seismometer, which capture the ground motion in all three dimensions: vertical, east, west, and north-south. However, as this study clearly shows, building on these achievements where DAS record can do what traditional seismometers could, and even more, will undoubtedly pave the way for truly next-generation earthquake observation network using fiber optic cables. So I found research like this, which could cleverly use the existing infrastructure, to be really fascinating. For instance, you see a lot of it even here in London, where I live. Hundreds of years old buildings were being beautifully renovated with the latest technology, and I just feel like there's so much value in these kind of techniques and leverage what's already there. Since starting this show, I've realized that innovative research coming out of Japan, like today's topic, truly seems endless. I know I tend to pick studies that I personally find interesting, so there might be some bias in my choices, or perhaps some parts are a bit hard to follow at times, but I really hope you are enjoying it nonetheless. Okay, so Science Pod is delivered every weekday morning in Japanese and English. As today's research demonstrates, amazing scientific news is being released daily from research institutions here in Japan. So I'd love for you listeners to post your notes and comments after listening to the podcast using the hashtag SciencePod. See you next time.